So the last set of matrices that we're going to be looking at is we're going to be looking at the addition matrices. All right, and these are the elementary row operation matrices that allow us to add scalar multiples of two rows. All right, so let's say, for example, what I'm looking at, I've got 1, 3, and this is -2 and 4. Okay, and what I want to do is I want to zero out this row. Okay, so what I'm going to do is I'm going to add 2 of row 1 to row 2. Okay, so that'll be row 2 plus 2 row 1. If you want to rewrite it that way. And what that's going to end up giving me, okay, is 1, 3, and then 0, 10. Okay? Now, what we're going to do, right, notice that we have 1 and 2 and then 2. So it's being multiplied by, row 1 is being multiplied by 2. So my elementary matrix is going to look like this. It's going to have a 1 and a 1 on the diagonal. So it's going to be the identity matrix. And then the row that I'm actually going to be changing, I'm going to be multiplying it by the scalar that I'm changing it by. Okay? So that is 1, 0, 2, 1 is going to be my elementary row matrix in this case because I am changing the second row, okay, by multiplying it by 2. So we'll take that, multiply that 1, 3, -2, 4. Okay, so this is 1 times 1, 1, 0. Great. Good news on that one. That's going to keep that as a 1. And then this will keep as a 3. We didn't want that to change. Now 2 times 1 is, right, 2 times 1, 2 times 1 is 2, plus 1 times -2 is 0. Great. And 2 times 3 is 6, plus 1 times 4 is 10. And so you can see that by multiplying by that matrix, we in fact are going to be getting the correct resulting matrix. Okay? So that's pretty simple if what we want to do is we actually only want to change a 2 by 2 matrix, which a lot of the times, at least in this case, when we want to try and just kind of understand the concepts, it probably is what we want to do. But let's say, for example, I have a 3 by 3. So let's say I have 1, -1, 0, and then I have 2, 3, -2, and I have 5, 1, 3. Okay? And now what I want to do is I'm going to want to add, right? Add -5 of row 1 to row 3. Excuse me, to row 3. Okay? And so that's row 3 plus -5 times row 1. All right? And so what that's going to give me then is I'm going to get 1, -1, 0. Right? So that's not going to change. Second row is definitely not going to change. 2, 3, -2. All right? And then I'm going to get 0. And then -5 times -5 is 5, plus 1 is 6. And then 0 times -5 is 0, and that's 3. So I'm going to end up with 0, 6, 3. Okay? Now the matrix that I'm going to want to do to use in order to change this, it's going to have, we're going to notice that I'm actually, you notice I have 1, 2, okay? Or excuse me, 1, 3. I have A, 1, 3, -5. So the -5 is going to be the scalar that I'm going to place, and the -5 will go in the third row, first column. So the way we write it is, if this is Aij k, okay, then k goes in the ji column. So what that'll look like here in this case is it's going to look like this. It's going to have 1, 0, and then this is third row, first column, 1, 0, 0, 0, 1, 0, and then this will be -5, 0, 1. Multiply that now by 1, -1, 0, 2, 3, 2, 5, 1, 3. And what we get is we get 1 times 0, 1 times 1 is 1, 0, 0, so this is 1. Again, -1, 0, so those aren't going to change. Second row is also not going to change, 2, 3, 2. And then you can see we're now going to get -5 plus 0 plus 5, that's 0. -5 times -1, right, okay, is 5 plus 0 times 3 is 0, plus 1 is 6, and then negative 5 times 0 is 0, 0 times 2 is 0, and 1 times 3 is 3, and there's our 3. Okay? So basically, this is our rule for constructing these elementary matrices. Okay? If we have aijk, right, that is that we are changing the jth column, the jth row, by adding k multiples of I, then what we're going to do is we're going to have the identity matrix, all right, with k, that scalar, in the ji column. All right. In this example, we were changing the first and third, so we're going to put this in the third row, first column. Okay, and that's how you construct your addition matrices.